All right, welcome to Print Reading for Welders. This is Chapter 3. We're going to be going over notes and specifications today. So the objectives of this chapter, we're going to be able to identify the different types of paper sizes that we use for mechanical drawings. There are multiple forms. There's A, B, C, D, and E. They're all different sizes, A being the smallest size. I've got an example of a title block here, just printed out real quick. A is going to be the smallest, and it's about this size right here of a standard piece of paper. We're going to be able to identify the types of information contained within a drawing's title block, that being this right here. And we're going to be able to describe the difference between a general note and a local note, as well as identify the proper location for a specification. Notes specifications, they're not always possible to put all the information you need, whether it be drawn out or whether it be lines and dimensions. Sometimes you can include all the information you need just by, oh, you've got to build a trailer, these are the certain sizes. Well, what type of process do they want you to use in that specific location? How do they want you to weld it out? Is there preheating required? Is there not? Sometimes you can't get all the information you need just off of lines and dimensions to build the part or to build whatever you're trying to make. They're going to provide the additional information. Usually it's going to be lettered information concerning construction details. Prints, they like to scream, so everything's going to be capitalized. Sorry. Whenever they give you lettered information, it is going to be all in capital information. You're not going to have capital lowercase. It's all going to be in uppercase. Now, all the lettered information is going to explain, specify, or refer to the material or process needed to make that part. It'll let you know, are you using steel? What type of steel you're using? Which grade? If you're going to use a certain welding process, are you going to be stick welding, MIG welding? What type of amperage should you run? Are you going to have to preheat it, post-heat it, anything like that? This is all information that will be included in either a note or a specification. Now, a local note is only going to apply to a certain part on whatever print you're talking about, and is going to be placed near a view to best explain it. Whenever it is a local note, it is going to have a leader line going to it and pointing to that part that is talking about, or whatever part it is specifying. That'll be your local note. And the leader is going to go, the leader line is going to come down and indicate exactly where it needs to go. You can see on this slide, we have a local note that's letting you know that we have a 0.500 hole through. What it's talking about here is it has a 1/2 inch hole through this plate right here. That would be a local note. Now the other leader line with the 18/7, that is talking about item number or part number and a page number or detail numbering. That is a general note because it is referring to the part of this hole, while the note that is pointing to the hole, it is a local note because it is specifically talking about the 1/2 inch hole through the plate itself. Now, general notes applied to the drawing as a whole is going to be placed in an open space away from views. And then specific notes or specifications are going to be things like required materials, welding process, type and size of electrode, type and size of welding rod. Specifications are going to be located near the views to which they are referring to. Now, when there are multiple specifications are required, they are included on a separate sheet of paper reference to the drawing. So it'll have a leader line coming down saying reference spec A, reference spec B, reference spec C. And if it has those, it'll come with a sheet separate from the print, and it'll have all those specifications for you written out explaining what exactly it's talking about. It helps to keep the space on the print from being cluttered. That's why they do this, because you don't want all of this writing all over your print confusing you and just adding to more layers and more confusion on top of it. You want your prints to be clear and concise and let you know exactly what you're building right off the bat. So having all this information on a separate spec sheet helps to keep it from being cluttered and keeps all the information easily, it helps to make the information easier to find and easier to reference. General specifications are going to be placed within the title block, denoted specifications. So on the title block here, let's see, There's really two of the most important parts of any title block information you're going to have. First is going to be right here. It is going to be the name of the part. You need to make sure if they ask you, hey, I need you to build stop block number 37, and you've got a part over here in a print that says stop block number 36, you immediately know you screwed up. You've got the wrong print for the wrong part whenever you know you need to be working on stop block number 36, okay? Now the next part you need to check is the drawing number, and you can't see it on here, but usually there's a drawing number and a revision number as well. You need to make sure you are using the current revision. You could be on revision C, you could be on revision D. If they ask you to build a part and you're over here looking at the wrong revision number for what is ordered on your work order, and your print says revision number A instead of your work order saying revision number C, you know you've got the wrong print or the wrong revision of that print. So these are the two things you always need to check first whenever you get a print or whenever you're asked to build a part. Reference your work order. Do I have the right part? Do I have the right part name? And then go over here and make sure your drawing is the current drawing number or revision number. If it's not, you'll be building the wrong thing entirely and you'll have to go back and redo all your work. On this slide, you can see an example where it says we've got our welding symbol and it's got an arrow pointing down to a T-joint. Right there in the corner of that T-joint, it wants you to put a fillet weld. And in the tail of that welding symbol, it says C-Spec A. At the top of the print, it says specification A. It wants a number 20 1/4-inch bronze rod. So this is going to be a brazing process, and you're going to use that bronze rod to make that 1/4-inch fillet weld. Well, actually, you're going to use that bronze rod to make that fillet weld in that location. And so on the left, you see the symbol, and then on the right, you're going to see the significance of that symbol. So usually a title block is going to have this information. You're going to have the name of the part or project. You're going to have the quantity required, how many of them they need to make. Order number to reference to either your work order or to whatever project you're working on. Material, are you going to be using steel? What type of steel? A36, A56, AR500, all sorts of different steel. That's going to be in your material, that's going to be in your title block. Your scale size is very important because it'll let you know what scale you're working with. So if you need to draw a measurement off your print, you can transfer it to real life. Specifications in general, if there's a general specification such as preheating a part before welding it out, you're going to have information such as drawn by. You'll know which engineer drew this print or which drafter drew this print, so you can go back to them. Checked by. You need to make sure all your drawings, wherever you're working, have been checked by the lead engineer or whoever is in control of that project. You're going to have drawing number, very important. And you're going to also have date that the drawing was updated with that drawing number or specification. All information you need to know. Like I said, the name of the print and the drawing number and revision number are two of the most important things. Tolerances. The tolerances will let you know how large or how small you can go whenever you're working with this. If you can be an 1/8 inch oversized or an 1/8 inch undersize, you'll be able to know in the tolerances. Company name and revision record. So it's that revision record that I was talking about there, whether it's revision A, B, C, D, or if whether they used revisions 1, 2, 3, 4, 5, 6 to infinitum. So reference your drawing number or revision number and the name of the print. Now, we have 5 separate sizes of standard commercial mechanical drawing sheets. We have A, which is 8.5 by 11 inches. This piece of paper right here is an 8.5 by 11 inch piece of paper, just standard copy paper. Whenever you've got a B mechanical size drawing is 11 by 17 inches, so just imagine taking these 2 pieces of paper. This will be the most common print size you'll run into. 11 by 17, it's very simple to fold up, put away, to store, and it also provides enough area to describe most parts in the sufficient detail you need to build them. C, we step up to an 11 inch by 22 inch size piece of paper. D, we go to 22 inches by 34 inches. And then E, we go all the way to 34 inches by 44 inches. D and E are more used for plant layouts or architecture purposes. If you're building a building on a job site, you'll run into those sizes, but they are quite large. 34 inches is almost 3 feet, and then 44 inches is pretty close to 4 feet. It's 4 inches shy of 4 feet. So you imagine having a 3 foot wide by 4 foot wide piece of paper and trying to carry that around. It's pretty large, it's pretty bulky. You're only going to run into that on large projects for structures. If you're just building something like a trailer, you're probably going to run into a size B mechanical drawing, just 11 by 17 inches. All right. Letters may or may not be included as a part or drawing identification number. This just comes down to what the company has chosen to do. We can either identify drawings through numbers or we can identify drawings through letters. Now, they can also identify them through names, but they'll either have one or the other, so you can use either identification systems, numbers or letters. All right, so notes and specifications are going to add the information not available from lines and dimensions. Local notes only apply to one view. So if you have multiple views of a print and there's a note on one part of that print for one view, like let's say it's the right side view, that note's only going to apply to that view if it's a local note. Now, if it's a general note, it's going to apply to all of the views of that part. So local notes apply to one view, and a general note's going to apply to the entire drawing as a whole. Specifications located near views to which they refer may be included on a separate sheet of paper or may be included in a title block. So they can either be on a separate spec sheet if they have a lot of them, or all that information may be in a title block.